Okay, so in this video, we're going to take a look at trig ratios of special right triangles, starting with the 45, 45, 90. All right, let's say that both the legs of this 45, 45, 90 is just a length of 1, so they have a measure of 1, meaning the hypotenuse must be rad 2 because the hypotenuse is rad 2 times larger than each leg. So if each leg is 1, rad 2 times 1 is rad 2, so the hypotenuse is rad 2. Okay, so now I just want to use the trig ratios for a 45-degree angle from this right triangle, and I just want to write them in simplified fraction form. I don't want to use a calculator. All right, so let's start with sine. So if I'm taking, say, if I'm using sine, I recall that sine is opposite over hypotenuse. Okay, so if I'm doing sine of 45 degrees, then that would be my opposite, and it doesn't matter which one I do because they're both the same and you'll get the same outcome. So say I start here, my opposite is 1. And my hypotenuse is rad 2. I don't want to leave the radical in the denominator. I want to rationalize this. So I'm going to multiply the top and bottom by rad 2. 1 times rad 2 is just rad 2. Rad 2 times rad 2 is rad 4. I can't simplify rad 2 any further, so I leave it as rad 2, but with rad 4, that is a perfect square, so it just becomes 2. So sine of 45 degrees becomes rad 2 over 2. Let's go ahead and do the same thing with cosine. And I know cosine is adjacent over hypotenuse. So the cosine of 45 degrees would equal, if I'm looking at this angle, would equal 1 over rad 2. 1 over rad 2. Well, I'm going to save myself some time and effort since I know that sine of 45 degrees is 1 over rad 2, and we were able to simplify in fraction form to rad 2 over 2. That means I know that this would eventually convert to rad 2 over 2. So cosine of 45 degrees is rad 2 over 2 in simplified fraction form. The last one I'm going to take a look at is my tangent. And I know tangent is opposite over adjacent. Let's take tangent of 45 degrees. If I'm looking at this 45-degree angle over here, my opposite is 1, my adjacent is 1. Therefore, tangent is 1 over 1, which simplifies to 1. Isn't that nice? So again, to reiterate, sine of 45 is rad 2 over 2. Cosine of 45 degrees is rad 2 over 2, and tangent of 45 degrees is just 1. Now, let's take a look at the trig ratios for a 30, 60, 90 right triangle. And we're going to do something a little different here. I'm going to give you the shorter leg. I'm going to tell you that is a value of 1. What I want you to do is go ahead and find the length of the hypotenuse and the longer leg, knowing what we previously learned and the properties of a 30, 60, 90 triangle. So I'm going to go ahead and pause the video now and see if you can find the length of the hypotenuse and the longer leg. Okay, so you should have came up with a value of 2 for the hypotenuse because the shorter leg is 2 times, or I'm sorry, I should say the hypotenuse is 2 times the length of the shorter leg. And we know that the longer leg is rad 3 times as long as the shorter leg. Ask again. If you have any questions, please note that now so you can ask me when you see me in person. Okay, so now let's go ahead and find our trig ratios using this 30, 60, 90 triangle. So I'm going to start with sine, and I know sine is opposite over the hypotenuse, and I'm just getting in the habit of writing these ratios. If I want to take the sine of 30 degrees, so I'm going to start with 30 degrees, meaning I'm going to start with this angle up here, 30 degrees. That means I'm going to take the ratio of the opposite leg, which is 1, over the hypotenuse. So that just becomes 1 over 2. Okay, now I want to take sine of 60 degrees. So sine of 60 degrees. So I'm going to take a look at this angle right here. And I know that the opposite leg is rad 3, the hypotenuse is 2. So therefore, that ratio would be rad 3 over 2. And this is great. They're both in simplified fractional form. I don't have to do anything else. So sine of rad 30 is 1/2, and sine of 60 is rad 3 over 2. Fabulous. Now let's go ahead and find those trig ratio, or the trig ratios for cosine. I know cosine is adjacent over the hypotenuse. So let's go ahead and find cosine of 30 degrees. Go over here and take a look at 30 degrees. If it's adjacent, I know it has to be rad 3. And then the hypotenuse is 2. So that would be rad 3 over 2. Great, simplified fractional form. Don't have to do anything with it. Let's go ahead and find cosine of 60 degrees. I'm going to take a look at the 60 over here. Adjacent is 1, hypotenuse is 2, so cosine of 60 degrees is just 1/2. These are nice because we don't have to do anything else to simplify them. Also, note that sine of 30 degrees is cosine of 60 degrees. They have the same ratio. Sine of 60 degrees is the same as cosine of 30 degrees. They have the same ratio. That's just something to note. That might help you out on any kind of an assessment, just making those associations. The last one we're going to work out is tangent. Tangent is opposite over adjacent. So let's take a look at tangent of 30 degrees. So I'm going to go ahead and take a look at the 30-degree angle. My opposite is 1. My adjacent is rad 3. So therefore, it would be 1 over rad 3. The problem is I have a radical in the denominator. So let's go ahead and rationalize that by multiplying the top and bottom by rad 3. 1 times rad 3 is rad 3. Rad 3 times rad 3 is rad 9, but it's nice because 9 is a perfect square, so I'm left with rad 3 over 3. Let's go ahead and take tangent of 60 degrees. I'm going to take a look at my 60-degree angle, taking a look at my opposite, which is rad 3, over my adjacent. So I have rad 3 over 1. That simplifies to rad 3. So tangent of 60 degrees is rad 3, and tangent of 30 degrees is rad 3 over 3. And those are my trig ratios for a 30, 60, 90 triangle in simplest fractional form without using a calculator or converting them to a decimal.